applications to economics. So derivatives can also be used to predict things in economics, and we're going to find out in economics there's some stuff called marginal cost, marginal revenue, and marginal profit. And all of these are just the derivatives of your cost function, revenue function, and profit function. So in economics, or if you have a business, you are going to be interested in the revenue. That's how much money you bring in. Profit is how much you get after you subtract your costs from your revenue. So revenue is the total amount that you come in. When you subtract your costs from that, you find out how much money you're making. So here's a typical idea for a cost function, okay? Cost function here says if you build nothing, it still costs you $2,000 to get the machine ready so that it could build something, okay? So there's an initial just infrastructure kind of cost to making something. The more things you make, the cheaper they become to make them. Why? Well, if you're just buying supplies for one thing compared to someone who's buying supplies for 100 things, they usually can get their supplies cheaper than you can. So this cost function is saying that as you make more and more items, your cost will go down. So here's our cost function. If each item sells for $80, which would allow us to make a very easy revenue function. You sell one of them, your revenue is $80. You sell two of them, your revenue is $160. And then your profit function will be your revenue function minus your cost function, which would be 80x minus So if we combine our like terms, we've got a profit function for this equation. So 100 units are going to be manufactured. First of all, we're going to look at the marginal revenue. I like this one to start off with because the marginal revenue will just be your derivative of your revenue function. Our revenue function was 80x, because each one sold for $80. The derivative of this would be 80. And here the derivative actually matches up perfectly with this situation, okay? Marginal revenue is an estimate as to how much more revenue you will receive if you sold one more unit after 100. So you sold 100 of them. Does it make sense that if you sold one more, you would get an extra $80? Wow, the derivative is so miraculous here in showing us something that is common sense. If they all sell for $80, if you sell one more, you will increase your revenue by $80. Okay? So that's what your marginal revenue. And in our situation, we had such a simple equation that it just makes sense that it would be that way. Marginal cost, how much is it going to cost you to build one more? You've built 100 of them. Now, this will give us an estimate. How much will it cost to make one more? So we go to our cost function, take the derivative, and notice that that 2,000 goes away. Right? Why? Because that initial cost is already spent. And now we're just looking how much after the 100th one you want to produce one more. What would it cost? plug in 100, and you're estimating that to produce one more would cost you $36. And finally, your marginal profit, okay? An estimate of the profit to be gained. So we could either do our derivative this way, or we could take the equation that we have, and the equation that we had was 40x plus, when we take the derivative, we get 40x plus 0.04x. So to find the marginal profit, or what we'd expect to make if we produce the 100th one, well, you could either plug the 100th into that equation, and you would get 44, or you could take your answers that we had from our marginal revenue and our marginal cost, and we get the same answer. Again, these are estimates. If we wanted to figure out the actual cost of producing one more, what would we have to do? So this is an estimate. Let's go to the cost one, right? Just a reminder, this is an estimate. An estimate cost to produce one more after 100. The actual cost to produce one more, we would go and figure out how much does it cost to produce 101. Subtract how much did it cost to produce 100 of them, and what we would be left with is the exact cost to produce 101. Now we go to our calculator to do this. Our cost function, 40 times 101 minus 0.02. 101 squared plus 2,000. There we go. A lot more calculations to do to actually figure that out. How close was our derivative? Pretty close, right? The actual cost to produce one more, to go from 100 to 101, was $35.98. Whereas our marginal cost from our derivative said, hey, a good estimate would just be use the slope of the tangent and find out that it's 36. So sometimes, I think in your textbook questions, and sometimes I ask a similar thing to this on the test to see if we understand how marginal cost and marginal revenue work. You find your estimate, and then you go, I say, well, what was the actual cost, or what was the actual profit, or what was the actual revenue? Then you would have to calculate how much does it cost to produce 101? How much does it cost to produce 100? The difference would be how much it would cost to produce one more after 100, and guess that value. But the nice thing for economics is we can see that the derivative provides us with a very nice estimate of that, usually with a lot less work. Right? And this is typical at the beginning. we're not looking at making very much money. But as time goes on, we're going to be making more and more money, right? And you would probably be looking at your profit formula, your profit equation, which is, we have it here. Here's our profit equation. First of all, you'd be like, well, if I don't make any, I'm going to be losing money because I have this $2,000. At what point do I start making money? And then looking at, does this make sense? Does this not make sense? Sometimes companies can run models of what their plan is. And if their model says, you know what, we're going to put all of this money into something to begin with, but it's not going to pay us out, maybe this isn't worth doing. Maybe we have to look at something else. Okay, so